This is example of lashing calculations of a heavy module on SPMT trailer. As an example, I will take one big reactor, 455 tons. Here it is. Symmetric lashing will be. Here it is, sticked already, and we can proceed with selection of trailer. We'll select SPMT, and now we got it in scale with the smallest module. Let's start with 12 axles, it's not enough. 16 axles looking by length looking good, but transversally looking a little bit too short, and maximum loads are 90%. 90%, we make it double. It's looking much better. There is no need for any further adjustment of the cargo on the trailer, shifting forward and aft. It's in center, and we can proceed with the next step is definition of standard. We're going to apply for this calculation, and for this kind of transports on SPMTs is the best use heavy modules, direct calculation, and limit the speed of the trailer, and put conditions on of the road, minimum curve radius, wind speed, and slopes on the road. So let's try with 40 kilometers per hour. 20 kilometers was here by default. This is speed saved by default for SPMTs. Lashing is defined here. Characteristics of lashing are 180 kilonewtons minimum braking load, and 50% is maximum securing load. So it gives about 9 tons safe working load. Friction, cargo trailer 0.4. Okay, let's proceed. And now, first step is definition of number of lashing points we are going to start with. We can always later on remove some lashing point or add some more lashing points. It's not a problem. But let's start, as we have 4 cradles. Let's start with 4 lashing points, and let's confirm it. Once we confirm it, you see we got indication of coordinate system for side view and for front and rear view, ZY, ZX, and blinking lines at the edge of both pictures, indicating us where we are supposed to enter the first lashing point. There is an option to start with definition of inside view, and or to start with definition of in front or rear view. If you click first time here is front or rear view, then Z and Y coordinates will be defined immediately, automatically, and then in next step we'll define only X coordinate. Or in this case, if we are going to we start with side lashing, then we'll enter first point here, and after definition of ZX coordinates, we have to define only Y coordinate in this view here. Maybe explanation how it works. This is extract from from the menu. You can see here in 4 steps how we have to define every lashing point. So if we are talking about side lashing, so first step will be click in this area. If I am happy with the coordinates, then I will confirm it, and then in next step we'll confirm Y coordinate in this view and confirm it here. Or if in the case of rear forward lashing point definition. First step will be in this view. After that, you will have three options to define. This point will be end forward and aft, or will be only forward, or will be only aft. So you can choose one of these three bottoms, and after that, the X coordinate will be defined in this view here and confirmed by this bottom here. So that goes like that. Let's start with definition now of lashing points. So first we have to do click somewhere here. We can read coordinates X and Z in these boxes here. If we are not happy with them, we can correct them manually. And if we confirm it, now we got the circle here. Next step is to define Y coordinate, and after definition of this point, and after every click in this area, you see this small red line is following vertically, is following position of this lashing point. So this is just indication where our lashing point Y or in rear front view will be. Even if I click that much here, up, I can click it here, but it will end up here. Look, if I confirm it, you see, it is. And as it is symmetric lashing, we have both lashing points defined, port and starboard. So let's do the same for the next lashing point. Here we are. Third one. And yeah. And now, after definition of the last lashing point, lashing installation bottom is enabled, and you can click it. Here we are. You see that all this aft lashing is overstressed, and pretty much 331%. Let's see the loads. You see longitudinal aft. It means due to forward accelerations, due to braking. So aft lashing is taking, and after deduction of friction is taking for 143 tons. We still have 130 tons of force of load that is going to aft lashing. Forward lashing is taking only 25 tons. So, and these lashings are in green, so we have 1, 2, 3, 4, 8 of 9 tons, 70 tons because of angles and so on. They are fine. We can close it now. Transversal lashing transversally is not taking any centrifugal force. Centrifugal load is 92 tons, and we have friction of 140 tons, so there are no transversal load on the lashing. We can close it, and what we are supposed to do, let's see results. Click results and save to see what is going on. So you see all these longitudinal lashings are taking over 3 times more than they can take. We will go back, and what we can do is now we'll go back to lashing an environment, and the easiest way is to avoid increasing number of lashing points on the same location. We can double it. We can double it by entering here 360 minimum braking load. It means each lashing is of 360 kilonewtons. If we are using still the chains, 180 kilonewtons minimum breaking load. For every lashing we'll put 2 chains. Let's see. Now we are still far, 165%, they are overstressed, and because taking only aft lashing is overstressed, let's add 2 lashing points forward. We put it here, only forward. You see, now we have to go here, confirm, and another one forward. Here we are, lashing installation. Up. Still, it's too much. It is too much. And now let's add. Let's try with further reduction of speed, limiting speed, maybe of the trailer. If we limit speed to 30 kilometers per hour, lashing installation, still a little bit overstressed. And now let's add one more lashing forward, here, forward, here, confirm X, lashing installation. Now it's fine, 92% of capacity. And that's it. Now we can proceed with results. Here they are. You can see for all seven lashing points. You can see the results. You can see total number of lashings, and bear in mind they are double. If you are using chains of 180 kilonewtons minimum breaking load, everything is indicated here. Maximum securing load, cargo data, calculated loads in center of gravity, lashing data, and so on, and road wind friction and these environmental conditions. We can proceed to see more numerical results. Here are coordinates of all lashing points. Type of lashing, this is side or forward. You can see the angles of all lashing points, longitudinal and transversal angles, both starboard. You can see here angle coefficients, calculated of course from these angles, and percentage of total lashing that was applied in calculation of stress in every lashing. You can see the last page of the calculation, length coefficients, and transversal coefficients applied in calculations. And uneven tensioning coefficient here, 1.35, is applied, and you can see that effective working load limit for this lashing, no, bear in mind is double, is 133 tons, so 13.5 tons is effective working load limit. Now we can go back again, and we can print complete report. Save. Printing is going straight to default printer of the computer. So if you are connected to some other printer, it will be automatically printed. In my case, this is PDF. Now you can see full range of results. There are 6 pages. You can see that this is lashing calculate type of lashing is symmetric, and combined. It means that lashing installed is valid for transversal and longitudinal loads. Here is position condition are the data of the cargo. This is a picture of lashing with coordinates of all points. Here are the stresses in each lashing and theoretical lengths of lashing. Stresses, dynamic loads calculated in G. In G are indicated here, just to have them for comparison. If you're using some of the standard lashings, which are usually expressed in G. Usually forward, if you take a European IMO standard, longitudinal forward is 0.8, transversal is 0.5, and after longitudinally after 0.5, and vertically 0 or 0.2. Here it is, and we can close it and can exit from this. That's the end.